What if the universe didn't have gravity? We exist. What even is gravity?
We all know that gravity is the force that pulls us down, but it's much more complicated than that. First of all, it keeps our planet habitable. Since it keeps our atmosphere intact, it's the reason I can stand here without the sun harming me. But what actually is gravity? To answer that question, I invited a special guest. Let me welcome Neil deGrasse Tyson.
What is
You
gravity?
have no idea. Okay, next question.
No, not yet. Well, we still do not know what gravity actually is yet. We can still piece together information that we know today. And we all know if I ended the video right there, me and my roommates are getting this grade. Unlike me having an existential crisis when seeing an apple fall down, a scientist named Sir Isaac Newton asked why the apple fell down. That's when he realized there was a force that caused that apple to fall down, which we know today as gravity. But what does down actually mean? To pay tribute to Sir Isaac Newton, let's use this apple to represent our planet and this rubber band to represent gravity. If I were to put my finger inside the rubber band, no matter where it is, it's gonna get pulled towards the apple as long as it's still inside the rubber band. Now let's imagine the same effect but not with the rubber band, instead the apple's leaf. This is when we realize it's not just getting pulled down, but instead it's getting pulled towards the center of the earth. I mean, we see this every day. This vaccination card falls down, this pen falls down. My modules, on the other hand, yeah, that's a different problem. So we know how gravity works based on our interactions here on Earth, but a physicist named Albert Einstein worked on a theory called general relativity, which changed our view on gravity. It's a whole new different topic I cannot discuss in this video, but to put simply, space-time tells matter how to move, and matter tells space-time how to curve. Let me explain. Let this handkerchief represent space-time. If we have mass, we see that it bends space-time. Now take an object with more mass, this apple for instance, we see that it bends space-time much more. Now if we take more objects that have significantly less mass, we see that the portion of space-time being bended by the apple attracts the objects with less mass towards the apple. This is just a simple representation, but with this in mind we can take some notes. First, all matter has a gravitational pull since it can bend space-time. Second, the larger an object's mass is, the more it can bend space-time. To put both ideas together, the larger an object's mass is, the more gravitational pull it has. While I may have given you more questions about gravity, I still hope you learned a lot. I mean, that's the beauty of science. It's a cycle of asking and learning. So, keep asking those questions and always stay curious.